Ladies and gentlemen, in this video, we're talking about how to compare and order real numbers. So things like perfect squares, non-perfect squares, fractions, mixed numbers, percentages, terminating, repeating decimals, and we need to get them into the same form. In this case, we're going to convert them all to decimals, but the caveat with this is that I'm going to show you how to do it all without a calculator. If you're on this lesson right now in school, if you have a calculator, then this should be a very, very easy lesson for you, as long as you know how to punch things into a calculator properly. But if you're not given a calculator, I want to make sure that you're successful as well, and you know how to convert all of these to decimals. So let's go ahead and get into the video.
Chaos and endless roads. We broke off a bit more than I was told, but the fate isn't mine alone.
Now, when we compare and order real numbers, our goal here is to convert every single number that we have into a decimal, because then it's very, very easy to compare all of our numbers. But if we're dealing with things like square roots, terminating decimals, mixed numbers, it's almost impossible to figure out, well, which one is the smallest, which one's the largest, which one goes in the middle, which is why we need to get them in the same exact format, in this case, decimals being the easiest. So I gave us a lot of space, that's why I moved my camera all the way down to the bottom right here. And now let's go ahead and take a look at number one and see if we can order these values below in ascending order. Now, if you're not sure what ascending means, that means from least to greatest or smallest to largest. So I'm just going to jot that above the word ascending. So least to greatest. And now let's go ahead and take a look at our values. Our first one that we have is -4 3/5. So we have a mixed number right now, but again, we want to get it into a decimal. So we know our decimal is going to start off with -4 point something, but how do I convert this fraction into a decimal? So I'm going to go ahead and show you the math of how to do that. Some of you might know what 3/5 is as a decimal already and kind of can tack it onto that -4, but if you're not sure, I'm going to show you how to do it. So our numerator is going to go on the inside, which is the 3, and then on the outside is going to be the 5. So how many times does 5 fit into the number 3? Well, it doesn't. You can't fit a larger number into a smaller number. So we're just going to put a 0 up top here. But the only problem is that we're out of numbers. So to continue our division problem, we need to add a decimal point behind the 3, and then we're going to annex a 0 here. And now we can continue dividing. So I'm going to move my decimal point up into our final answer, or our quotient. Now, how many times does 5 fit into the number 30? Well, 5 fits into 30 6 times perfectly. 5 times 6 is 30. We subtract and we end up getting a remainder of 0. So now we can go ahead and tack on 0.6 behind that -4 point that we had originally. And now we're done with the first one. For our second one, we already have a decimal, which is nice. We don't have to do anything. But you're going to notice that it goes to the hundredths place, whereas our first decimal only goes to the tenths place. We want to make sure that we're also going to the same exact place value behind the decimal point. So how do I make -4.6 go to the hundredths place? All we have to do is tack on a 0 behind it, because it's not going to change the value of this decimal at all. So now we have -4 60 hundredths and 4 73 hundredths. So we're done with the first two. Now let's go ahead and tackle number 3, and we have 9 halves. So it's going to be almost identical to what we just did. We're going to put 9 in the inside and 2 on the outside. Let's go ahead and extend this out a little bit. How many times does 2 fit into the number 9? Well, 2 fits into 9 4 times. 2 times 4 is 8, so let's go ahead and subtract that from 9. 9 minus 8 is 1. How many times does 2 fit into 1? Well, it doesn't, but again, we're out of numbers. So to continue, let's add a decimal point, annex a 0, move that decimal point up into our final answer, and then we can go ahead and bring down that 0 and continue. How many times does 2 fit into the number 10 now? Well, it fits 5 times perfectly, and then we're going to end up getting a remainder of 0. So our final answer for our decimal is going to be 4 5/10. But again, we want to go to the hundredths place just so it matches all the other ones. So we're just going to tack on a 0 there, and we're done with our third one. Now for our fourth one, we have the square root of 21, which kind of stinks because it's a non-perfect square. These are a little bit tough, especially without a calculator, because we're not going to get the exact value. We're going to have to estimate here. And I'm going to show you the best way to go about estimating non-perfect squares. So I want you to picture a number line. So let's go ahead and draw out a number line here. Now, what two perfect squares is the square root of 21 between? Well, the two perfect squares that I think of are the square root of 16, which we're going to put on this end. The square root of 16 we know is the number 4. And on the other end of the number line would be the square root of 25, which is 5. The square root of 16 is 4 because, well, what is 4 times itself, or 4 squared, where you're going to get 16 back? Whereas for the square root of 25, that's 5 squared, or 5 times 5. So I want to figure out what goes perfectly in the middle. We know it's going to be 4.5, but what's the square root that gives us 4.5 back? Well, that would be 4.5 squared, or 4.5 times itself. So let's go ahead and do that math first. And the way that I like to multiply decimals is we're going to do 4.5 times 4.5. And I see a lot of students mess this up. I want you to tell me how many numbers are behind both of our decimal points. And you should know that there's 2. There's one number behind the decimal point in the first 4.5, and there's one behind the other one. So in parentheses on the side here, I'm going to put the number 2. All that means is that there's 2 numbers behind both decimal points in total. And I'm going to multiply 45 times 45, and I'm going to simply ignore the decimal point for now, and then we'll add it back in at the very end. So what is 5 times 5? It's 25. Let's go ahead and do that. I accidentally erased there. 5 times 5 is 25. We carry the 2. 5 times 4 is 20, plus 2 is going to give us 22. Then when we move down to the next line, let's add a 0 first. 4 times 5 is 20. We carry the 2. 4 times 4 is 16, plus 2 gives us 18. And now we can go ahead and add these up. 5 plus 0 is 5. 2 plus 0 is 2. 2 plus 8 is 10. We carry that 1. And we end up getting 2,025, which obviously doesn't make any sense. But remember, we have that 2 in parentheses. That means there's going to be 2 numbers behind our decimal point in our final answer, which means our decimal point should go between the 0 and the 2. So to get 4.5 as a final answer, that's going to be 20.25. If you took the square root of 20 and 25 hundredths, you're going to end up getting exactly 4.5 back. So now that we can narrow this down, let's go ahead and take a look at our number line. So the square root of 21, where does this fall on the number line? Well, 21, is it between 16 and 20 and 25 hundredths? Or is it between 20 and 25 hundredths and 25? Well, you should know it's between 20.25 and 25. So we know it's bigger than 4.5 or 4.5. But it's definitely closer to 4.5 because 21 is a lot closer to 20.25 than it is to 25. So the best estimate that we could give this, we know it's going to end up somewhere over here. So it's not going to be 4.5, but a good estimate for this would be 4.6. And let's go ahead and write that up here directly below the square root of 21. And we just want to make sure that we bring it to the hundredths place because, again, we want to be able to compare properly with all the other ones. So now let's go ahead and get rid of our number line here and take a look at the last one. And it's nice because it's already a decimal, but we're dealing with a repeating decimal. So we have -4 to start. And we know this 5 is repeating forever and ever. So we know the tens place is going to have a 5 in it. The hundredths place is going to have a 5 in it. And then we're just going to put ... because that 5 is going to go on infinitely. Now that we have everything in the correct format, everything's a decimal now, and it's going to the hundredths place, we can now order these in ascending order, or least to greatest. So which decimal is the smallest, or the most negative in this case? And that's going to be -4 and 60 hundredths. All I'm going to do, though, is write the original value, which was -4 and 3/5. And then we can cross that out because that one's done and placed properly. Now, which one is the next smallest? Well, it's going to be the only other one that's negative, which is the -4.5 repeating. So we can cross that one out now. That one's done. And now we're on to all the positive decimals. Well, which one is the next smallest? We have 4 and 50 hundredths, 4 and 60 hundredths, and 4 and 73 hundredths. Well, they all start with 4. So which number is the smallest then? Well, 50 is the smallest. So it's going to be 9/2. Then we have the square root of 21 right after. And then finally, the very last one is going to be 4 and 73 hundredths. And we are done with the first one. I know it takes a little bit of time, but I want to make sure that you know the ins and outs of how to convert all of these into decimals. Now let's go ahead and make our way over to number 2. So this time around, we're ordering the values below from greatest to least, or biggest to smallest. So what's nice about the first one is that's the square root of 9. That's a perfect square. Well, what number can you multiply by itself to give you 9? In this case, it's 3. So let's go ahead and do 3, and to make it into a decimal, we're just going to do 3.0. Now our next one is pi. All of us should know by now that pi is an irrational number. It's just a number that goes on infinitely. And almost everybody knows that the beginning couple digits are 3.14. So if you don't know that, you're simply just going to have to memorize that. So 3 and 14 hundredths. Now, because we're in the hundredths place now, I'm going to backtrack a little bit and just tack on a 0 here, so that one goes to the hundredths place as well. Now let's go ahead and take a look at the third one. We have 3.1 repeating, so very similar to our previous question. It starts with 3 point, and we know the 1's going to be in the tens place and the hundredths place, and then I'm just going to put a ... afterwards because that's going to go on infinitely. Now let's take a look at the fourth one. These ones can be a little bit tricky. What is going on between 2 and the square root of 3 if you don't see anything? Well, if you don't see anything, we can assume that they're being multiplied together. So this is 2 times the square root of 3, which unfortunately is a non-perfect square. So just like we did with number 1, we're going to make a number line, see what 2 perfect squares this falls between, and then we're going to have to estimate roughly what it's going to be. And then we're going to have to multiply it by 2. So it does take a little bit of work. I know it's a little bit of a headache, but again, I want to make sure that you know how to do every single type of example that your teacher might be able to throw at you. So let's go ahead and make a number line. And we know the square root of 3 falls between the perfect square of 1 and the perfect square of 4. Well, square root of 1 just gives 1 back because 1 times 1 is 1. And the square root of 4 is going to be 2 because 2 times 2 is 4. So we want to figure out, well, what square root gives us 1.5 back? And just like we did in the previous one, we can figure that out by doing 1.5 times itself. So we're going to do 1.5 times 1.5. There's 2 numbers behind the decimal point, so I'm just going to put that in parentheses on the side here. And we're going to multiply 15 by 15, ignoring the decimal points for right now. 5 times 5 is 25. We carry the 2. 5 times 1 is 5, plus 2 gives us 7. On the next line, we add a 0. 1 times 5 is 5. 1 times 1 is 1. And now we can go ahead and add these. 5 plus 0 is 5. 7 plus 5 is 12. Carry that 1. And we end up getting 225. But remember that parentheses, that 2, tells us there's 2 numbers behind the decimal point. So the square root that gives us 1.5 back is the square root of 2.25, or 2 and 25 hundredths. And now let's go ahead and erase all that work there. Now that we have this number line, we then need to see, where does the square root of 3 fall? Is it between the square root of 1 and the square root of 2.25? Well, no, 3 doesn't fall between those numbers. So we know the answer has to be bigger than 1.5. Now, where does it fall between 2.25 and 4? Well, it's slightly closer to 2.25. It's 0.75 away from 2 and 25 hundredths, but it's 1.25 away, or sorry, 1 away from 4. So that means it's slightly closer to 1.5, not by a ton, but I wouldn't say 1.6 is a good estimate. We're going to say that a good estimate for this would be 1.7, because again, it's leaning closer into the middle than it is to the number 2. So that's our good estimate. Let's go ahead and get rid of our number line here. But we're not done quite yet. We now need to do 1.7 times 2, because it was a multiplying problem originally. So we're going to do 1.7 times 2. We have 1 number behind the decimal point, so we're just going to ignore that for now, and we're simply just going to do 17 times 2. 2 times 7 is 14. We carry the 1. 2 times 1 is 2, plus 1 is 3. And there's 1 number behind the decimal point, and we end up getting 3.4. We want to make sure that it goes to the hundredths place though, so we're just going to tack on a 0. And again, it's not 100% accurate. That's an estimate, but it's pretty close. Now let's go ahead and take a look at the last one. We have pi divided by 2. So we know pi, again, we can use the first couple digits, which is 3.14. So let's put 3.14 on the inside, and let's divide it by 2. And let's move that decimal point up into the final answer. 2 fits into the number 3 one time. 2 times 1 is 2. Let's go ahead and subtract here. 3 minus 2 is 1. 2 doesn't fit into 1 at all, so let's move that 1 down. 2 fits into 11 5 times. 2 times 5 is 10. We subtract, we get a remainder of 1. 2 doesn't fit into 1, we bring that 4 down, and 2 fits into 14 7 times perfectly. We subtract, we get a remainder of 0. So our answer for this one is 1 and 57/100ths. And now everything is in the correct format, which is a decimal, and they all go to the hundredths place. Now we can go ahead and order these from largest to smallest. So the biggest decimal that we have looks like it's going to be 3 and 40/100ths, or 2 square root of 3. So we're going to put that first. Then we get rid of that. Our next largest one is going to be 3.14, because 14 is bigger than 11 here. So that's going to be pi. After that, we have 3.1 repeating. Then we have 3, which is going to be the square root of 9. And then finally, definitely our smallest one, which was easy to tell because it starts with a 1, whereas all the other ones start with 3, is going to be 1 and 57/100ths, or pi over 2. So let me actually write pi over 2, just because we followed that with all the other ones. Okay, now let's move on to the last one before we have 3 practice problems to try out on your own, which is going to be a little bit of a challenge, but I want you to try to work through all of those as best as you possibly can, just on a scratch piece of paper, but we'll see those in a little bit. Now let's go ahead and take a look at number 3. So we're going to order the values below in descending order. So we already did ascending, which is least to greatest, but descending is going to be the exact opposite, which is going to be greatest to least. For 48%, we need to know, well, how do you convert a percentage into a decimal? Well, if you don't see a decimal point in 48%, it's always at the end of the number. So this technically has a decimal point behind it. And to convert it to a decimal, we need to move it 2 place values to the left. So let's move it once in front of the 8, and then twice in front of the 4. And we're going to end up getting 0 and 48/100ths for the first one. And I noticed just a little bit further ahead, we do have a decimal, though, that goes to the thousands place. So I'm just going to do this ahead of time and simply tack on a 0 here, just because we're going to be working in the thousands place. Now let's go ahead and take a look at the second one, which is a repeating decimal, and it looks like that 8 is repeating. So we have 0.48, and then we're just going to extend it to one more 8. That way it goes to the thousands, followed by a ... Now let's move on to the fraction, which is 3/7. So just like we did before, we're going to be doing some division here. So the 3 is on the inside, 7 is on the outside. 7 does not fit into 3 at all, so that's 0. And to continue this, we're going to put a decimal point followed by a 0. Move that decimal point up into our final answer. 7 fits into 30 4 times. 7 times 4 is 28. We subtract, we get a remainder of 2. Well, 7 doesn't fit into 2, so we add a 0, bring it down. 7 fits into 20 twice. 7 times 2 is 14. We subtract, we get a remainder of 6. We add another 0 and bring it down. 7 fits into 68 times. That's 56. We subtract, we get a remainder of 4. And we can stop here. Even though it keeps going, we know we're working all the way to the thousands place. So 3/7 is going to be 0.428. And we know it continues. I'm just going to put a ... there, just because it technically doesn't end. We're only working to the thousands place, though. And then finally, let's go ahead and take a look at our other fraction, which is -4/9. So again, we're going to be doing some division here. 4 divided by 9. 9 does not fit into 4 at all, so we put a 0. And then to continue, we add a decimal point and a 0. Move that up into our final answer. 9 fits into 40 4 times. 9 times 4 is 36. We subtract, we get a remainder of 4. 9 doesn't fit into 4, so we add a 0, bring it down. 9 fits into 40 4 times again. 9 times 4 is 36. We subtract, we get a remainder of 4. And you're going to notice this is going to continue endlessly, which means this is going to be a repeating decimal. So we have negative 0.444 dot dot dot. And now we can go ahead and actually compare these now. So again, we're going from greatest to least. So which one of these is the largest this time around? And these ones are very, very close. You have to be careful. But it looks like we have 0.488. So that repeating decimal is going to be the largest. So let's go ahead and write that down below here. 0.48 with a bar over the 8. We can cross that out. And now on to the next one is 48% is going to be the next largest one. Then after that, the only one that could be next is the one that's not negative, which is 3/7. Now we're dealing with negatives. Which one is the least negative, which is going to be negative 4/9. And then finally, the smallest value or the most negative is going to be negative 0.463 or negative 463 thousandths. And those are the three examples I wanted to show you. Now let's go ahead and make our way over to the practice session. Right, ladies and gentlemen, if you made it this far, do you have what it takes to get a perfect score in this practice session? If you can do this, very, very nice job. This is one of the toughest lessons that I've filmed so far, especially if you're not using a calculator. So I encourage you to pause the video here, try out all three of these questions just on a scratch piece of paper, and when you think you're ready to go and you have them all ordered properly, play the video and see how you did. So I'm assuming at this point you've tried out all three and you're ready to see, did you get a perfect score? Let's go ahead and jump into number one. We are ordering these values from least to greatest, and right off the bat, we started you with a non-perfect square. So let's go ahead and draw a number line right off the bat because we need to estimate this as best as we possibly can. We know it's between the two perfect squares of the square root of 25 and the square root of 36. The square root of 25 is 5, the square root of 36 is 6, but then we need to figure out, well, what square root perfectly puts us in the middle there at 5.5. So just like we did before, we're going to do 5.5 times itself. There's two numbers behind the decimal points. We're just going to put a 2 in parentheses, and now we're going to go ahead and multiply, ignoring the decimals entirely. So we're going to do 55 times 55. 5 times 5 is 25. We carry the 2. 5 times 5 is 25 plus 2 is 27. We move down to the next line by adding a 0. 5 times 5 is 25. We carry the 2. 5 times 5 is 25 plus 2 is 27. And now we can go ahead and add these. 5 plus 0 is 5. 7 plus 5 is 12. We carry the 1. 7 plus 2 is 9 plus 1 gives us 10. We carry the 1. And we end up getting 3,025. And the decimal point will be right between that 0 and 2. So the square root that gives us 5.5 back is the square root of 30 and 25 hundredths for 5.5. So now we need to figure out, well, where does the square root of 27 fall? That way we can estimate it. Well, the square root of 27 falls between 25 and 30 and 25 hundredths. But 27 is two numbers away from 25, but it's 3.25 away from 30.25. So it's leaning closer to 5 than it is 5.5. So I'm going to say a good estimate for this is going to be right around 5.2. So let's go ahead and do 5.2 because that's still leaning it closer to 5 than it is to 5.5. So we'll go with 5.2 for that. And it looks like we're dealing with decimals that go to the hundredths place just because I see one in the hundredths place a little bit further down. So we're going to do 5.20 or 5 and 25 hundredths for the first one. Now let's go ahead and take a look at our percentage. To convert our percentage into a decimal, we know there's a decimal point at the end here, and we need to move it 2 place values to the left. So we have 0.58 for this one. Our next one, 5 and 37 hundredths, that's already done for us. It goes to the hundredths place, which is nice. And now we're down to a improper fraction and a mixed number. So a little bit of division for both of these. So 32 is on the inside, 5 is on the outside. 5 fits into 3 0 times, 5 fits into 32 6 times. 5 times 6 is 30. We subtract, we get a remainder of 2, but then we run out of numbers, so to continue, we have a 0.0 added on there. move our decimal point up into our final answer, and then we bring down that 0. 5 fits into 24 times perfectly. We subtract, we get a remainder of 0, and our decimal for this is going to be 6 4/10, and we're just going to bring it to the hundreds place. That way it matches all the other ones. And now we're on to our very last one. So we know it's going to start with 5 point something, and now we need to do division once again. So 1 on the inside, 3 on the outside. 3 does not fit into 1 at all, so we're going to put a 0 there. We're going to tack on that 0.0 to continue this. How many times does 3 fit into 10? Well, it fits 3 times. 3 times 3 is 9. We subtract, we get a remainder of 1. We add another 0, bring it down. 3 fits into 10 3 times, and you're going to notice that it's going to be a repeating decimal. So this is going to be 5.3 repeating, and we're just going to put 2 3s followed by a ... signifying that it's repeating. And now we can go ahead and actually order these from least to greatest. So which one of these is the smallest? Well, we can easily tell that this is going to be 58% because it doesn't even have a 5 at the beginning of the decimal. So that's the smallest. So we cross that out. Our next smallest is going to be 5.20, which is the non-perfect square of 27. After that, it looks like we have our mixed number of 5 1/3. Then we have our terminating decimal of 5.37. And then finally, the only one that's in the sixes is our improper fraction of 32/5. If you got number 1 right, very, very nice job. Now let's go ahead and make our way over to number 2. So we are ordering the values below in ascending order, which again means from least to greatest. So we have a mixed number to start, which means it looks like we're going to be doing some division once again. We know it starts with negative 11 point something, and now we need to do 3 divided by 8. So 8 doesn't fit into 3 at all, so to continue we tack on that 0.0, move the decimal point up into our quotient or final answer. 8 fits into 30 3 times. 8 times 3 is 24. We subtract, we get a remainder of 6. 8 doesn't fit into 6 at all, so we add on another 0, bring it down. 8 fits into 60 7 times. 8 times 7 is 56. We subtract, we get a remainder of 4. We tack on another 0, bring it down. 8 fits into 40 perfectly 5 times, so when we subtract, we get a remainder of 0. So our final answer for this one is going to be negative 11 375 thousandths for the first one. So let's go ahead and get rid of our division here. And now we're on to number 2, which is an improper fraction. It looks like we are doing division once again. So 56 is on the inside, 5 is on the outside. 5 fits into 5 1 time. 5 times 1 is 5. We subtract, we get a remainder of 0. We bring down that 6. 5 fits into 6 1 time. 5 times 1 is 5. We subtract, we get a remainder of 1. And then we're out of numbers. So we tack on that decimal point and a 0. We move that decimal point up into our final answer. We can bring down this 0. 5 fits into 10 twice perfectly. 5 times 2 is 10. We subtract, we get a remainder of 0. And our final answer for this one is going to be negative 11.2. And I'm just going to add on 2 zeros to bring it to the thousands place. And then we can move on to our third one. This one's going to be incredibly nice. I love when perfect squares show up because the square root of 144 is 12. We just need to make sure that we put the negative there. So it's going to be negative 12.000. Again, we just want to make sure that we go to the same place value. That way there's no possible way you can make an error and look at something in the hundreds and something's in the thousands, then you end up putting them in the wrong spot. Then let's go ahead and take a look at our repeating decimal, which is nice because these are easy to kind of just figure out. This is negative 11.444 ... because that 4 is going to go on forever. And then finally, the very last one is negative 4 pi. Well, again, if you don't see an operation between the two of them, we can assume that we're multiplying here. So we're going to use 3.14 just like we did with the previous questions and do 3.14 times 4 for this. So we have 3.14 times 4. There's 2 numbers behind the decimal point in total, so we're going to put that 2 there, and then we can go ahead and multiply here. This is going to be 314 times 4. 4 times 4 is 16. We carry the 1. 4 times 1 is 4 plus 1 is 5. 4 times 3 is 12. and there's two numbers behind the decimal point, so it's going to go between the 2 and the 5. And then we just want to make sure that this final answer is going to be negative. So we end up getting negative 12.56, and we just want to tack on a 0. That way it goes to the thousands place. And now we can go ahead and actually order these in ascending order, or least to greatest. So for least, we have to be very careful here because we want the one that is the most negative. And negative numbers always screw people up with this. So the one that's the furthest away from 0 is going to be negative 4 pi, because that's the most negative number that we have. So negative 4 pi. That one's done. The next smallest is going to be negative square root of 144, because that's negative 12. So that one's done. The next one that's the furthest away looks like it's the repeating decimal of negative 11.4 repeating. That one's done. Then we have negative 11 and 3/8. And then finally, the one that's the least negative, or technically the largest, because it's the closest to being a positive number, is the improper fraction of negative 56 over 5. If you got that one, nice job. Let's move into our final one. Order the values below in descending order. So that is going to be greatest to least, or largest to smallest. And now let's go ahead and convert all these into decimals. So we know our percentage, we have a decimal point behind it. If we don't see it, we're going to move it 2 place values to the left. So we get 0.84. We know we're going to have to go to the thousands place just because I'm looking at the next number. So I'm going to tack on a 0 here. Our second one's already done, which is nice. And now we're on to the fraction, which means we're doing division once again. So we have 8/9. 9 doesn't fit into 8 at all, so we have to tack on that 0.0, move that decimal point up into our final answer. 9 fits into 80 8 times. 9 times 8 is 72. We subtract, we get a remainder of 8. 9 doesn't fit into 8 at all, so we tack on a 0, move that down. 9 fits into 80 8 times. 9 times 8 is 72. We subtract, we get a remainder of 8. And you're going to notice that this is going to be one of those ones that's a repeating decimal. So we're just going to take it to the thousands place just because all the other ones are. So this is going to be 0.888 ... And then we can move on to our non-perfect square, which means once again we're going to have to estimate, which I think is the most time-consuming ones out of all the ones that we deal with. So let's go ahead and make a number line. So the square root of 78 falls between the two perfect squares of the square root of 64 and the perfect square of 81, or it's going to be between 8 and 9. So we want to figure out, well, what value gives us 8.5? So just like we did with all the other ones, we're going to do 8.5 times 8.5. So 8.5 times 8.5. We know there's two numbers behind the decimal points in total, so we're simply just going to do 85 times 85. 5 times 5 is 25. We carry the 2. 5 times 8 is 40, plus 2 is 42. When we move down to the next line, we're going to add a 0. 8 times 5 is 40. We carry the 4. 8 times 8 is 64, plus 4 gives us 68. Now we can go ahead and add these. We get 5, 2, 12, carry the 1, and then we put our decimal point. So it's two numbers behind the decimal point, and we end up getting the square root of 72 and 25/100ths. Now we need to figure out, well, where does the square root of 78 fit in all of this? Well, you should know it's definitely going to be between 72 and 25/100ths and 81. So we know it's between 8.5 and 9. Well, 78 is relatively close to 81. It's only 3 numbers away. So a good estimate for this is we're going to give it 8.8 in this case. So let's go with 8.8 for our estimate. We'll get rid of all of this. And we'll do 8.800. And then finally, the very last one is a repeating decimal. So it's going to be 0.8, and the 5's repeating. We'll take it to the thousands place. And now we can go ahead and order these in descending order, or largest to smallest. So the largest decimal by far is the one that has the 8 starting out, which is going to be the square root of 78. So that one is done. Then after that, which one is the next largest? And it looks like it's going to be the 888, which is 8/9. After that, we have 855, which is going to be our repeating decimal. Then we're going to have 84% by a little bit. And then finally, the last one is our terminating decimal at 836 thousandths. If you went 3 for 3, very, very nice job. This is an incredibly challenging topic, especially if you're not given a calculator. So I hope this video helped you out. If it did, leave a like on the video, comment any other topics you want to see in the future, and subscribe. Turn on that bell for post notifications to know when I upload next. And we'll see you in the next one with some more mathematics. Again, thank you for taking the time to watch.
Nothing's gotta change, nothing stays the same. Change your lemonade.